In this video, we are going to learn 5.3 solids. There are 4 learning outcomes. A. Explain the fixed shape of a solid. B. Apply the kinetic concepts to explain the process, freezing, melting, sublimation, and deposition. C. Differentiate amorphous and crystalline solids. And D. State the type of crystalline solid: metallic, ionic, molecular covalent, and giant covalent. Before we start, the first keyword is sublimations. I repeat, the first keyword is sublimation. Properties of solid. The particles are arranged very closely together and they have little empty spaces. The particles have strong forces between them, and they can only vibrate and rotate about fixed position, and they cannot move freely. Solid has definite shape and volume, high densities, and they are incompressible. The following diagram describes the arrangement of particles in gas, liquid, and solid. We can see in the diagram for solid, the particles are arranged so closely and packed together. The following phase changes describe the changes between solid, liquid, and gas. In this video, we are going to focus on freezing, melting, sublimation, and deposition. Take note, students, please correct the spelling for melting. Thank you. Freezing, or another word is solidification, a process where liquid is changed to solid. When a liquid is cool, kinetic energy of liquid particles decrease. The liquid particles vibrate at a slower rate. The liquid particles will then move closer to each other, and at its freezing point, the interparticle forces are strong enough to hold the particles together in a fixed and orderly arrangement, so the liquid freezes. The second one is melting, or another word is fusion, the process where solid is changed to liquid. When a solid substance is heated, kinetic energy of solid particles increases. The particles vibrate more quickly and energetically. At its melting point, the particles have enough energy to overcome the interparticle forces, or the vibrations disrupt the orderly solid structure. Then, the particles slip past one another, loses its definite shape, and converted to liquid. The solid melts. The third one is sublimation, the process where solid is changed to gas. When a solid substance is heated, kinetic energy of solid particles increases abruptly. The particles vibrate very vigorously that they straight away change to the disordered arrangement of gas. Thus, the solid sublimes to gas without going through liquid phase. The last one is deposition, the process where gas is changed to solid. If a gas is supercooled, kinetic energy of gas particles decreases abruptly. The particles move very closely to each other and straight away change to the orderly arrangement of solid. Thus, the gas changes to solid without go through the liquid phase. There are two types of solid. The first one is crystalline solid, and the second one is amorphous solid. The difference are, for crystalline solid, the atoms, ions, or molecules occupy specific position, while for amorphous solid, they have random 3D arrangement of particles. Crystalline solid is formed when a saturated liquid is cooled slowly, while amorphous solid is formed when a saturated liquid is cooled rapidly. Crystalline solid has regular 3D arrangement and occupy fixed position, while amorphous solid lacks the well-defined arrangement. Examples for crystalline solid are ice, sugar, and salt, while for amorphous solid, the examples are glass, plastic material, charcoal, and rubber. Crystalline solid can be divided into 4 groups, which are ionic solid, molecular covalent solid, giant covalent solid, and metallic solid. The first one is molecular covalent solids. They compose of molecules or atoms held together by van der Waals forces. Examples are P4, S8, iodine, and dry ice, which is actually a solid CO2. The second one is giant covalent solids. They are a very large atoms or molecules. They compose of atoms linked together by a network of covalent bonds. Examples include diamond and graphite quartz, which is SiO2. The third one is ionic solids. They consist of ions which are cation and anion held together by ionic bonds or electrostatic force. Examples include NaCl and Ki. The following diagram shows some examples of ionic solids: azurite, iron pyrite or pigment, and potassium nitrate crystal. The last one is metallic solids. They are close-packed structure composed of atoms of the same metal linked together by metallic bond. Examples are all metallic elements such as sodium, magnesium, and ferrum. If you remember, we studied this in chapter 4. Okeylah, last sekali kita buat summary lah untuk crystalline solids ni. Dia ada 4, ionic, molecular covalent, giant covalent dan juga metallic. Setiap kategori ada perbezaan dia dan ada different example dia lah. So boleh baca semula dekat sini ataupun tengok pada slide yang terakhir ni. Dalam slide yang terakhir ni kita tunjuk kategori solid yang ada, iaitu molecular, covalent, ionic dan juga metallic. Kemudian unit particles yang ada untuk setiap jenis solid, dia punya intermolecular forces, properties dan juga example. So slide yang terakhir ni lagi mudah lah untuk bezakan keempat-empat kategori crystalline solids. Okey, so kita summarize sedikit apa yang kita belajar dalam video ni. Yang pertama, properties of solid. Yang kedua, phase changes, iaitu freezing, melting, sublimation dan deposition. Kemudian kita belajar differentiate between crystalline solids dan juga amorphous solid. Dan last sekali, 4 kategori di bawah tajuk crystalline solids. Dan kata kunci terakhir dalam video ini adalah amorphous. Okay, so itu saja kelas. Thank you.